All right. Yesterday we worked on algebraic expressions. Today we're going to work on how you write and translate algebraic expressions. So word phrases can be written as algebraic expressions. Sometimes sentences can too, but sentences a lot of times will be equations. So to do this, we use a variable. And we know that variables often are letters. They can be other symbols. Today we'll just stick with letters though. Okay, so to remember, let's review some common phrases that mean add, subtract, multiply, and divide. I know you have other sets of notes for this. I'm just going to go over some of the most basic ones. Some words that mean add would be to combine, the sum, if something increases, more than, and then we know the inverse of addition is subtraction. So over here then we'd have less than, to decrease, to remove, the difference. We come up with a lot of phrases. For multiplying, times something times something. If we have rows of or the product of, and always we look for that word of. Make that word stick out in your notes. To duplicate something, to make copies, any of that stuff. To divide, how much something goes into something else. When we separate into parts, when we split something. And the big one that should stick out in your notes is the word per. Spend a lot of time with that when we get to unit rates and ratio. All right, so let's look at some examples. So if we're starting with 7 and we're decreasing by b, so we started with 7 and we subtracted b, 7 minus b. That is our algebraic phrase. The product of 19 and k. So 19 times k. Now that's not how you write it. Don't write it like this. Also, don't write it 19.k. The way we write it in algebra is 19k. Not k19, 19k. We write the number and then we write the variable, 19k. Okay, next example, combine that number with 8. We don't know what that number is. So now we need to have a variable. So we need to, what we call, define a variable. So we're going to say let, and whatever variable we want, I'm going to use n because the number starts with n. Let n represent that number. So it's a let, the phrase is let, whatever the variable is, represent whatever we want it to represent. So let n represent that number. So now combine that number with 8. So we have n plus 8. Does order matter with addition? No, it will later with some other things. 49 split into w parts. This one order matters. We start with 49 and we're dividing it into w parts. Or you can write it this way, and I want you to write it this way in your notes too, 49 over w as a fraction. Okay, so my warning for you, the order of your phrase matters when you do two operations. Well, we already said when you do division. And the other operation that it matters with is subtraction. With adding or multiplying, you can use either order. I guess I should have written divide and subtract. You can't always just go left to right. Think about what you are starting with. Whatever you start with, you write first. Okay, so here's some examples. 23 less than m. So what am I starting with? 23 or m? That's right, we start with m. So m minus 23. 3 more than y. What are we starting with? Not 3, it's 3 more than y. So it's y plus 3. Okay, 8 parts divided from W acres. So we're starting with W acres, and we're dividing it into 8 parts. W divided by 8, or W over 8. 32 less than what you have. Ooh, we don't have a variable here, what you have. So we have to define it. Let, I'm going to say W. W represent what you have. You can't write words in algebra. So W minus 32. We're starting with what you have, and we're subtracting 32. Okay, we're going to do some more examples here. Write an algebraic expression to describe Jerry's age. Use the following information. Jerry is 4 years younger than his brother Steve. So first we have to know how old Steve is. We don't have an age for Steve, so we need to define an variable. So let's use S for Steve. Let S represent Steve's age. Now that we have a variable for Steve's age, we can use it to determine Jerry's age. Jerry is 4 years younger than Steve. So it's not going to be 4 minus Steve's age. We're starting with Steve's age, and we're subtracting 4. That'll give us Jerry's age. S minus 4. When I cross things out in my notes, you don't have to do the same. I'm doing that for a visual for you. So if Steve is 22 years old, then how old's Jerry? Well, if Steve S equals 22, we can plug 22 in for our algebraic expression. That gives us 22 minus 4, so Steve would be 18. Before we move on, we want to make sure that makes sense. So we can take that 18 and plug it in up here. Jerry is 4 years younger than his brother Steve. So if Jerry's 18, Steve's 22. Okay, that makes sense. Always, always, always do that step. Okay, so now let's write an expression for a real world situation. Last year there were D pies baked for the bake sale. This year there were 198 pies baked. Using D, write an expression for the total number of pies baked in 2 years. Okay, so we have 2 years. We want to know the total amount. So we're going to do D plus 198. Or you can write 198 plus D. It doesn't matter which comes first when we add. Okay, the second one. Kelly had C deck of cards. Each deck has 52 cards. Using C, write an expression for the total number of cards Kelly has. So each deck has 52 cards. She has C decks. We could make this, we could illustrate this. We could use our kiter techniques. So we could be like, okay, there's one deck of 52, another deck of 52. We don't know how many decks. There's C decks. So this is going to be repeated addition or multiplication. C times 52. That's not how we write it in algebra. We write it 52C. Christine just spent several dollars on some earbuds. She had $139 in her piggy bank. Define a variable, then write an algebraic expression. Okay, so what do we need a variable for? We need a variable for what several dollars is. Okay, so let's do S represent, it's not the, it's how much money she spent on earbuds. Let S represent the money spent on earbuds. So we know it's several dollars. We don't know how much. So what did she start with? 139 or S? Yeah, 139. So she's starting with 139. And then we're subtracting S from that. And that's how much money she has left. All right, a couple more review. 15 more than G. So what are we starting with? Starting with G plus 15. 20 separated into C groups. we're starting with C. No, we're starting with 20. I apologize. 20 divided by C, 20, and we're separating it. We're taking 20 and we're splitting it into C groups. So it's a division problem. 7 rows of Y. So if we have Y, 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 we have 7 rows of this. So that's 7Y. 4 less than Z. We're starting with Z, and we're doing 4 less. All right, that is how we do algebraic expressions. That's how we write it and translate it.